Alrighty, we are gonna finish chapter 9. 9.2 is the biggest of these sections. 9.3 is literally a slide. We're gonna like, hey, there it is. And then 9.4 is fairly straightforward, and we have a little bitty activity. I probably won't record the activity, but I don't know, it's pretty straightforward, all of these, which is nice because the last couple have been kind of weird. We will need table 7. We won't need it a lot today, but going forward, when we talk about this type of test, we'll need that table to look stuff up. I'll explain how to look it up, like how to use the table today, and then we'll use it more later. But if you have the ebook, it's open the ebook, get to the full book, and then look in the appendix, and that's where all of the tables are if you haven't found those yet. Okay, so estimating a population mean. So again, we're making some inferences about our populations. This one deals with a T distribution. So I always called it a T test for the obvious reasons, because it's a T. Our formula is T equals X bar minus mu all over standard deviation over root N. Everything else should be fairly familiar. So do note that we have a sample and a population mean in here. A lot of times, well, I think chapter 10 or 11, we deal with this. When we do these things, we normalize our mean, we assume it's going to be 0. So the population mean is 0 for like the Z chart sort of thing. And then we're going to guesstimate that our sample mean will be a little bit different. So, but that's future work. We're actually not going to use this equation today. I was looking the notes. I'm like, oh, they tell us this, but they don't have us use this. Okay, then. So hey, there's the formula. Okay. In dealing with T tests, we have degrees of freedom. Oh, my handwriting is worse than normal today. And we use the ever so clever DF for this. And most of the time, it's going to be N minus 1. So number of participants minus 1. What our degrees of freedom is say we were given a population or a sample, whatever, and we know our mean is this value. Well, all but one of our other values can be crazy, whatever we want, but the last value has to be one number in particular to make our mean match. So it's basically how many numbers can vary like crazy and still get okay to the mean we're looking for. I'm going to shut this. There's so yeah. Not that it's gonna help. So, we get, yeah, N minus 1. This is where our table comes in. It's this chart here. So, oof, this is hard to read. Can I zoom in? Yeah. For now, we're just going to talk about how to read the table. If we want area to the right of the tail, so you'll notice we don't look at left and right like we did with the Z, we're just looking to the right. So say we want a 0.05 significance level. So we look for this guy here. So that's the column we're going to look at. And then we need to calculate our degrees of freedom. So let's say we had 9 participants. Our degrees of freedom would be 8 then. It's N minus 1. So we scroll down to the 8. Come over here. Our T value we would need is 1.860. Now, again, we're not going to use this for anything yet. We'll have to look these up for our alphas, but what else we do with them is coming in the future. So we'll come back to this guy in a sec. We have a confidence interval. Confidence interval. And again, we're saying that 95% of our samples are going to fall within this. And to calculate this, it's our mean. We're going to take a plus and we're minus T alpha over 2 times S over our N. And this is, we're going to look up our T alpha over 2 from the chart. And we use degrees of freedom equals N minus 1. Okay, I'm going to give us the other equation, then we'll actually use one of these. Our margin of error, we actually already have that on the screen. This is going to be E equals T alpha over 2 times standard deviation over root N. So a lot like the stuff we did last time with our z-scores. And I think we were, population parameters. So, wow, words are hard today. Ratios, proportions sort of thing. So similar vibe. That, okay. I did not write an example down, which is unlike me. So let's say we have a population mean equals 25. And in our sample, we have, what does my table go to? We're gonna have, can I do that? No, 38, why not? And our alpha level is a 0.05. All of these numbers are going to be given to you. I'm pulling them out of the air today just because. So we're going to figure out what our confidence interval is. First thing we need to figure out is, oh, I don't have a standard deviation here. Whoops. We're going to make this up as 2.5. Sure. So we need our T alpha over 2. So our T value we're going to look up, our alpha number, so 0.05 over 2 is the 0.025. Our degrees of freedom is the number in our pool, minus 1, 37. Writing those down so I don't lose them. Okay. First thing I'm going to do is look up here. Where's my alpha over 2 level? So 0.025. Oh, wrong thing. So it should be right under here, if we can see that, this middle column. And so I'm going to keep my finger on the middle column. My degrees of freedom were 37. So there's my 37. It looks like my T value is 2.026. Okay. We'll write that over here. So we find now we're going to find our confidence interval. So we take our mean. Is 25. Oops. All right, let me actually write down the formula and then I'll talk my way through it. Okay, so there's my formula. My mean is 25. And then I'm gonna have a plus or minus. And my T alpha over 2 was 2.026 times my standard deviation, 2.5 over the square root of my n, which is 38. I forgot to bring my fancy calculator, so phone calculator it is. If I can find it. Here we go. Okay, I'm gonna do a little side math first. So 2.026 times 2.5 divided by square root of 38. Oh, can somebody grab the door for me, please? Sorry, the door outside is so loud. It's really loud out there. Okay, so this value here I find is 0.822. So then I get 25 plus or minus that. Now I'm going to turn it into two separate pieces. So 25 minus that gives me 24.178. Oh, I should be able to do that one in my head. 25.822. So, if I can get most of this on the screen, we find that our population is probably going to be between 24.2 and 25.8. So since our sample size was bigger than normal, our confidence interval is smaller, which is good. We want as small a confidence interval as possible because then we can narrow down as to what we think our value is going to really be. So that gives us the best idea. And again, we're saying that 95% of our samples should be within this interval. So fall around here somewhere. I'll scroll back up once we're done and so you can see the top if you want. Yeah. Okay. The last piece of this is determining a sample size for the error rate that we want. So I gotta scroll, I'm sorry. Ideally, you want your sample size to be as big as possible, but a lot of times it's not feasible to have a huge sample size because it takes more time and money to get all of those. So we figure out what's the minimum sample size we can get for what we want. In this case, the book gave me a Z alpha over 2. That's felt weird, but I was going to give what they did. Felt like it should be a Z, or excuse me, a T. But this is what they had. And again, our error rate is what I gave before. So plug that in, and that'll give you the minimum sample size you need for a particular margin of error. A lot of times you want your error to be like 0.5%, or I want to say political polls have like an error rate of 2%. So it could be 2% above or below 2 percentage points. Just kind of depends on what you're looking at, how important it is. Okay, I'm actually going to pause my video. Nine point two.